Hi guys, in this video we are going to do a quick review of all the rules of exponents and a few practice problems. Now there are a lot of exponent rules when you add, when you multiply, when you subtract. All of that can be hard for people to remember, so we have a little mnemonic device for you that hopefully will be helpful. You can see that ANMARMDS sort of down the middle of the page. This is just one method of helping you remember when you do what? When dealing with exponents. So you could make up whatever mnemonic device you want for this, whatever, if you've got an idea of something to help you remember those letters. What I have is Aunt Nancy made a real mess downstairs. Now, that's just made up. Again, it could be anything that you can hopefully remember. But what this does is it tells you a list of steps of when you do what. So this first one, AN, stands for when you add, and I'd have to put in or subtract. You do nothing to your exponents. Remember, these are exponent rules, not base rules. So let me give you an example of what I mean. If I had 3x squared plus 4x squared, those are definitely like terms. I can add the coefficients. That would give me 7x squared. Notice I do nothing to the exponent. The exponent does not change. I'm just adding my coefficients. So if you're dealing with a problem and there are exponents in it, and the operation is addition or subtraction of the bases, right? These guys down here, you're going to do nothing with the exponents. You're just going to add the bases. All right, the MA stands for, I'm trying to color coordinate, let's go green. MA stands for, if you're going to multiply the bases, then you add the exponents. And I'm not going to write that out. I'm just going to put add. You add the exponents. So for example, on that, if I have, let's say 3x cubed times 4x squared, I'm going to multiply my bases, right? 3 times 4 is clearly 12, but my exponents I'm going to add. 3 plus 2 would give me 5 total x's. So remember, that's 3 times x, right? Exponents are short for telling you how many times you're repeatedly multiplying the same base. So I've got 3 x's in the first group and 2 x's in the second group altogether. That's a total of 5. The next RM, the real mess that we've got going on here, stands for if you're raising to a power, you multiply. And again, I'm just going to remind you, we're talking about the exponents. So if I have something like 3x squared cubed, I have bases, and then I have a variable with an exponent. The base just gets raised to the power. That is 3 cubed times x squared cubed. It's the exponents that I multiply. So 3 cubed would give me 27, x to the 6th. Sorry, I'm running a little bit out of space there. And then the last one, maybe you can guess, the one thing we haven't done yet, D stands for divide. So if you are dividing bases, then you are going to subtract the exponents. So for example, if I had x to the 5th divided by x to the 3rd, that would give me x to the 5 minus 3, or x squared. And of course, that only works for like bases. If I have x to the 5th over y to the 3rd, obviously those don't even combine at all. They're totally different bases. Now sometimes, I'm going to give you another example over here with my subtraction problem. If what happens to be on top, if the numerator is smaller than the denominator, then I'm going to get x to the 2 minus 5, which would give me a negative exponent. And we tend to, in standard form, not want to leave anything with negative exponents. So that brings us to this next rule that's down here, that if you ever have a base that's being raised to a negative power, that negative power in the exponent is telling you to move it. If it's in the numerator. It's saying, hey, move me to the denominator and I'll be positive. Right? There's this sort of, he's unhappy where he lives, you've got to move him. So that means if he already lived in the denominator, let's say I had 2 and on the bottom y to the -4th, right? That y is unhappy in the denominator. He moves up to the numerator and now he's happy. 2 doesn't move at all. The 2 didn't have a negative exponent. It stays where it is. All right. Now my next rule has to do with fractional exponents. It's probably been a little while since you've done this, but here's how this works. Rational exponents, when you have fractional exponents, that does reflect a radical. So your numerator is going to stay the power on the base, and the denominator is the index of the radical. So to give you an example of how that might work, you might see something like 4 to the 1/2 power, for example. That just means 4 is being raised to the first power, which is just 4, and then I'm square rooting 4. So that's one example. And then the very last one, anything to the power of 0, I'm sure you remember, is 1. All right, so that's the basic list of rules of how you deal with exponents. I'm going to encourage you to pause the video and try. You have just these 2 examples, example 1, example 2. At least try example 1. Just quickly go through, fill them out, pause the video, and then join me back and see how you did. All right, so the first 3, I've got basically the 3 numbers, 3 to the power of 4, and I'm playing with what difference it makes where I place the negative. So remember that with powers affect what's directly in front of them. So in this case, what is directly in front of that 4 is the parenthesis. So that means everything in the parenthesis gets multiplied out 4 times. So I'm going to end up with -3 times -3 times -3 times -3. And 4 negatives in a row would be a positive, and 3 to the 4th power is an 81. So that would be positive 81. That is different from when the 3 is not in parentheses. What's directly in front of the exponent now is just the 3. So the negative sign does not get repeated 4 times. Just the 3 gets repeated 4 times. So now my answer will be -81. That is an important distinction and tends to mess a lot of students up. Now, C, you have a negative exponent, so just remember, he's just saying to you, I don't like where I live, you need to move me, and I move him down into the denominator, and now I've got a positive exponent, and I can simplify that as 1 over 81, and that is a positive value. There's nothing, the base was never negative, and it's not going to be after I raise it to the power. All right, D, I have like bases that are being divided. So I'm going to use that division. For divide, I subtract the exponents. So that's 5 to the power of 23 minus 21, or 5 squared, which I know is 25. Now, E, you can look at that a couple of different ways. I have 2 to the -2 power and 3 to the -2 power. So both the numerator and the denominator do not like where they live, so we just switch them. That would be 3 to the +2 in the numerator and 2 to the +2 in the denominator, which would give me 9/4 for an answer. So some people would see a fraction raised to a negative power and automatically flip everything, right? It would be like 3 over 2. Now it's to a +2. You'd get the same answer, 9 over 4. So it just depends on what you want to do first. If you want to distribute, or if you want to flip and get rid of the negative. Either way, you get the same answer. And then letter F, I've got a negative exponent, which automatically moves that 16 down to the denominator. Now the exponent's positive, and I can deal with the rational part of it. So 16 is my base, the power is 3, the index is 4. It does not matter if you want to go 16 to the 3rd power and then simplify it. I find it easier to take the root first. It makes my numbers smaller. The fourth root of 16 is 2, and 2 cubed is 8. I have no idea what 16 cubed is, so it would have been harder for me to do that in my head. But my final answer is 1/8. All right, if you haven't already tried example 2, maybe pause the video. These are definitely, at least A and C, more challenging. Pause the video, try them. That is how you get good. Okay, so example 2A, I have lots of things going on here, right? I'm going to be multiplying my like bases, so I am going to have to add some exponents, but I also have something being raised to a power. So I'm using two different rules. I am going to have to take care of this power first. So I have 1, 2, 3 items in that group of parentheses. I'm going to raise all of them to the power of 2. So that would be 4 squared, a squared, b to the 4th, and I hate that those are both 2's because you might be thinking I'm definitely multiplying. That 2 times 2 is 4. It's just unfortunate that so is 2 plus 2. Now I can multiply and combine all my like bases. This is it's just multiplication, right? I can reorder this however I want. 3 times 16 is multiplying. I've got an a cubed, basically 3 a's there and 2 a's later, or at the another part of it. Altogether that would be a to the 5th, and then I've got b cubed times b to the 4th power, which gives me b to the 7th. B is a nice little quick problem. Anything to the power of 0 is 1. And then the last one, the monster problem, you have some choices. Some people might choose to work inside first and simplify and then take care of that power. And some people would choose to take care of the power first. There really isn't a right or wrong answer here, but I see that I have fractional exponents that will disappear when I multiply them all by 2, and I don't really want to, right? These fractions have denominators of 2, so I can see that those fractions will disappear if I choose to multiply first, and I can see that some of my negatives might disappear if I choose to multiply first. So I'm going to just distribute that -2 and deal with what comes next, but it is totally up to you. I end up here then with 3 to the -2 power. X 3/2 times -2 is going to leave me with -3. So that's x to the -3rd, y to the -6th. In the denominator, I'm going to get x to the -4th because I'm multiplying. And y, -1/2 times the -2 cancels. I get a positive first power. All right, now I can sort of clean up anything that's like terms. I see this 3 has a negative exponent, so I'm going to move it down. That's going to be 9 in the denominator, 3 squared in the denominator. Maybe I should do that a little slower just so I don't lose anybody. 3 to the +2 in the denominator. I see my x's, I guess, depending on how you want to do this, I can move x to the 4th up and x to the 3rd down. I can, this y that's positive is fine, and move y to the 6th down below. Is one way of looking at it. You could have just subtracted, I suppose. I see now I have 4 x's in the top, 3 in the bottom. I'm going to subtract, and the extra is up top. And then I've got 7 y's down in the denominator. So I chose to get rid of all the negatives first, and then added what was left over, and that would be my final answer. All right, guys, that is a lot of a review on this topic, so hopefully that helps.